Guys, so this video is on integer multiplication and division, but what I want you to be able to do by the end of this video is have a conceptual understanding of why the rules for multiplying and dividing integers work. Okay, so that's where we're going to focus, because I think a lot of you guys already know these rules, so we're just going to look at why they work and then review the rules in case you're not comfortable with them. All right, here we go. So multiplication is just repeated addition. And that's what I want us to remember when we look at the rules for multiplying integers, okay? So we know three groups of 4, okay? Three groups of 4 can be written as 3 times 4 or 4 plus 4 plus 4, where we literally have three groups of 4. And we know that the answer to this is 12. And this is just basic review, okay? But if you think about it like this, for groups of 3, we know that the commutative property of multiplication allows us to write it backwards and still have the same answer of 12, but our groupings have changed. Instead of having 3 groups of 4, now we have 4 groups of 3. So you can read these forwards or you can read these backwards. Doesn't matter. And when we apply this to negative numbers, this is what occurs. So I want you to ask yourself, how would that principle apply to negative numbers? So 3 groups of negative 4. You've probably guessed already that that would be 3 times negative 4. So what does that look like exactly? Well, maybe as you would have expected, negative 4 plus negative 4 plus negative 4, which equals negative 12. So there's a slight pattern that's going to emerge here. I just want you to note that we had a positive integer of 3 being multiplied by a negative integer of 4 that got us 3 groups of negative 4. And as you guys remember from our integer addition, if you add a bunch of negatives together, you just simply end up with a negative as you go further left on the number line. And we can say it the opposite way too. 4 groups of negative 3. And of course that problem would look a little different. Like 4 times negative 3, which would be negative 3 plus negative 3 plus negative 3 plus negative 3, still coming out to negative 12. So notice that in each one of these examples there's one negative, and because of repeated addition, the product will be negative when one of the factors is negative. All right. How does it apply though if we have 2 negatives? So here we have negative 3 groups of negative 4. Things get a little weird now and maybe a little less intuitive. So if you have negative 3 times negative 4, what's this going to look like in terms of repeated addition? That's the question here. So notice we have our 3 groups of negative 4, but it's negative 3 groups of negative 4. So you can take each one of these groups right here of negative 4 and distribute this negative sign to each one. And if you guys remember what happens when you have a double negative, you end up with a positive. So each one of these 4s becomes a positive 4 and you end up with a positive product of 12. So that's an interesting fact, that when you have 2 negatives being multiplied together, because you have a double negative on that grouping, you end up with a positive product. And this applies the other way as well. Negative 4 groups of negative 3, excuse me, negative 4 groups of negative 3. And I'll just let you look at this. Same idea. So you don't necessarily ever need to write this out, when you're doing math. You're not going to take the time to write out the repeated addition, but I want you to know why these rules work. So what we've seen is if you have one negative and one positive, we know the answer is going to be negative. But what we've seen here is if you have 2 negatives, the answer is going to be positive. And you probably can tell right off the bat right here that I made a mistake and I forgot to change this to a positive 12. That should be a positive 12 because all these 3's become positive. Okay? My mistake on that. All right. Don't forget about division. And one of the ways I wanted to explain division was just using these triangles really quick. So we know that 12 divided by 3 is 4. And so the way these triangles work, if you haven't seen them, is you can, let me grab something that you can follow along with here. You can follow the line, so to speak. So 12 divided by 3 equals 4. 12 divided by 4 equals 3. And then 3 times 4 equals 12. These triangles always work. So if we plug in negative with these triangles, it kind of gives us a good idea of why the quotients have to be positive or negative. All right, so here's our first example. We have a positive number divided by a negative 3. So as you can see, we know that negative 3 times negative 4 would be positive 12. So because we know that we need another negative to make this positive, we know that the 4 must become negative. So then we can follow the triangle. Okay, 12 divided by negative 3 is negative 4, and 12 divided by negative 4 is negative 3. So I'm using the triangle to try and show you why I know this 4 must be negative. Because we know we have a positive 12 on top, and we know we're dividing it by negative 3. But whatever number goes here needs to also be negative because we have a positive product. And the two numbers on the bottom need to multiply together to be the one on the top of this triangle. One more quick example. If you have a double negative, what happens? It gets a little different, okay? So negative 12 divided by negative 3 is going to equal positive 4. And we can apply the same logic here. We know that the two numbers on the bottom of this triangle need to multiply to equal the number on the top. And because of what we've just learned in multiplication, we know that this must be a positive 4, because the only thing times negative 3 that's going to get us to negative 12 is positive 4. So it really is that simple. Now I've been talking at you about repeated addition and these division triangles. We can make this a lot simpler. So if your brain's spinning in circles right now, you're going, okay, I kind of understand what he's talking about. It really isn't hard. All I've been trying to do for the last 5 minutes is try to give you a good understanding of why these rules work. But now we can formulate the rules. We've seen a pattern. And so I ask you, what happens if the signs of two numbers in multiplication or division are the same? So what happens, for example, if you multiply two positives together or multiply two negatives together? And I want you to think about that. Okay? What happens if the signs are different? What happens if one number is negative and one number is positive in division or multiplication? Well, as it turns out, and it really is this simple, in multiplication and division, if the signs are the same, it's always going to be positive. And if the signs are different, your quotient or your product, the answer to your division or multiplication problem, is always going to be negative. And as you can see, that is derived from a pattern and from logic based on repeated addition and our understanding of division. All right, guys, there are some questions that I want you to answer on the website after this video. Good luck. I know you'll do well.